Section 8.2. Our objective today is I can state and apply the Pythagorean Theorem. So, the Pythagorean Theorem, everyone should have seen already in a previous class. So it says in a right triangle. So you have to start out with a right triangle. You have to know you have a right triangle. The square of the hypotenuse is equal to the sum of the squares of the legs. Okay, so if I have this right triangle where this is A, this is B, this is C, and C is my right angle, okay, then the side opposite A we'll call length A, the side opposite angle B we'll call length B, and the side opposite angle C, which is the hypotenuse, we'll call length C. And so as long as we know we have a right triangle, then we know for sure that A squared plus B squared equals C squared. Okay? And so we can use that fact to find unknown values. So for example, given the right triangle where this is 5, this is 12, and this is x, okay? X is the hypotenuse, so it represents C. So x squared is equal to 5 squared plus 12 squared, the sum of the legs squared. So 5 squared is 25, 12 squared is 144, so x squared equals 169. So x, if I take the square root of both sides, x equals 13. Because 13 times 13 is 169. Okay, example 2. If I have this right triangle, where this is 4, this is x, and the hypotenuse is 2 square root 5. So in this case, I know that 2 square root 5 squared is equal to 4 squared plus x squared. Well, 2 square root 5 squared means 2 square root 5 times 2 square root 5. So we do the 2 times the 2, which is 4, the square root 5 times the square root 5, which is square root 25, equals 4 squared is 16 plus x squared. Continue simplifying. So square root of 25 is 5, so 4 times 5. So we get 20 equals 16 plus x squared. Get x squared by itself. So 4 equals x squared. Take the square root. So x equals 2. Okay. Example 3. So if I have a parallelogram where I know this is a right angle, and I have this diagonal that we'll call x, and I know that this side is 9 and this side is 6. Okay, and so we know that in a parallelogram opposite angles are congruent, so this has to be a right angle. So then we know that x squared has to equal 6 squared plus 9 squared. So x squared equals 36 plus 81. So x squared equals 117. And so take the square root of both sides. So x is equal to the square root of 9 times 13, or x equals 3 square root 13. Okay, example 4. Find the length of the diagonals of a square with perimeter of 56. All right, so we have a square, and we know in the square that all the sides are congruent. And so if the perimeter is 56, we know that 4x equals 56. So divide both sides by 4. So x equals, let's see, it goes in 14 times. Okay, so x equals 14. So we know then that each of the sides is 14. So now if we put the diagonal in, we'll let that be y. So now we know that y squared is equal to 14 squared plus 14 squared. So y squared equals 196 plus 196, or y squared equals 2 times 196. So if we take the square root of both sides, we know y is equal to 14 square root 2. My example 5. The diagonals of a rhombus have lengths of 18 and 24. Find the perimeter of the rhombus. Okay, well, what do we know about rhombuses? Rhombuses are parallelograms that have 4 congruent sides. So it might look something like that, where these are all x. Okay, and we know that this is 18 and this is 24. But we also know that a rhombus is a parallelogram, so we know that the diagonals bisect each other. So we know then that this is 9 and this is 12. And we know that the diagonals are perpendicular to each other. So therefore, we can say that using this triangle right here, it's a right triangle, and so x is the hypotenuse, so we can say x squared equals 9 squared plus 12 squared. So x squared equals 81 plus 144. So x squared equals 225. Take the square root of both sides. And so we get x equals 15. Okay? But remember that the question is find the perimeter of the rhombus. Okay? So 4 times 15 equals 60. So the perimeter is 60 units.